about things on there. And then we'll actually do some graphs in Desmos so you can see how it works in there, which is much better. So this is section 1.3 anyway. So the main topic here is graphs of polynomial functions. Well, pretty much anyway. Most of them are polynomial functions. Some of them are not. All right, some of them are just regular functions. But they want to talk about some of the characteristics, I guess, of the graphs of the polynomial functions. So some of the characteristics, maybe. Characteristics. I'm going to mess this up. I don't even know why I decided I want to use characteristics. Some of the important parts, I'll just say. All right, of the graphs. Okay, that's what we're going to do. All right, so again, I'm going to draw some here, and then we'll put some into Desmos. There's a section in the textbook we should read and talk about what's in there, and we'll kind of go from there. All right, so I'm just going to draw a little graph here and put it in a different color. Like that. All right. So this, by the way, is a cubic polynomial. All right. Whether you know that or not, that's all right. I'm not going to ask you on a test either. But this is what it is. All right. We know that these are the x-intercepts, correct? And they also have the name of zeros, right? Okay. X-intercepts and zeros, same thing. So if I ask you for x-intercepts, there they are. If I ask you for zeros, there they are. The other important parts of graphs, though, are these points here and here. Okay? And those are called maximum, minimum, or minimum points. Right? And they are of interest to mathematicians, those particular points. All right, so we want to be able to find them. Right? Well, the only way you can really find them that we know how right now is to graph them. All right, so then we would type this function, whatever it is, into Desmos, and we would graph it and find those maximum, minimum points. All right. Some functions, however, do not have, well, some functions, I should say, particularly this one, does not necessarily have a maximum point by the term of maximum, because this graph continues, right? So we still say it has a maximum point here, but we don't call it a maximum. We call it a relative maximum. Or a relative minimum. I hope that's what they use. Because some people use, some books use local. Oh, sorry, scratch it. It's local. They use local here. Some books use relative, some books use local. It's the same thing, but it's a different word. Okay? So in this case, this has a local maximum right here and a local minimum right there, because this graph continues in both directions. Does that make sense? I mean, the minimum, this looks like a minimum, but its graphs keep continuing to go down, so it's not an absolute minimum. All right, it is a local minimum. Same thing here. This is a maximum, sure, but the graph continues to go up, so we call it a local maximum. If we have a graph that looks like this, right? This also has maximum, minimum points, right? There, and there, all right? Now, this one, though, is a minimum because the graph continues to go up this way, and never comes down. It's just continuing to go. All right? So this is called an absolute minimum. This would be called a local minimum. And this would be called a local maximum because the graph is continuing, right? And here, this is not the absolute minimum because this one is smaller, or, down. Right, so this one's down lower. So this one is the absolute minimum. This one's the local. And this is a local. Does that make sense? Right? Okay? So we can draw one like this. All right? And this is just going to go down. This is going to go down. And there they are. Right? So this one would be a absolute. What would this one be? Max, right? Okay. But then this one would have to be a local max. And then this one would be a local minimum. Okay? All right? Pretty simple. And I'll show you how to find them. It's really easy. All right? So then that's the information there. Okay? The other thing they talk about, and they're going to give you a graph. Let me give you one here. Now let's not go that extreme here. We'll make it too hard. All right, I'm going to put some points here. Let this one go. Let this one go. Let's say this is -3 and 5. And let's say this is 1 and -4. Okay. So those are our local, right, maximums. Okay. But also what they look at is they look at intervals of increasing and decreasing. So, when you do intervals of increasing or decreasing, you always start from the left and you go to the right. So you're going to start here. And we're going. So think of it kind of as a roller coaster. We're going up, correct? Does that make sense? Going up. So that's increasing. Right here at this point, by the way, if this is my roller coaster, it goes up, bump, 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 bump. Right here, there's a point where it's completely flat. Buy into that? That's that point. Okay? Then it's going to go streaming down. So this means that here, this function is doing what? Decreasing. Okay? Going down. And then you're going to get to this point again. Nothing's going on there. And then it's going to go back up. Right? So that's how you look at increasing, decreasing intervals. How would I write it? Well, let's start from here. So this function is increasing, we say here, right? From whatever this is to -3. Well, that is going to be -infinity. So we're going to go increasing. And I'm going to put a parenthesis. Negative, oops, got a little excited there. -infinity to whatever the x point is. Now you're only looking at the x, and this is kind of confusing, all right, in a sense that the y is what's increasing or decreasing, but the x values are the ones that you're putting in for the answer. Because as you go left to right, you're going along this horizontal x-axis, but you're looking at the graph in a vertical sense. So here we're going across. So we start at -infinity, and we get to negative 3, and we say, well, it's increasing. All right? So I write that down. Then, after that, it decreases. So now I'm going to put down decreasing from negative 3 to, well, what point? 1. Good. It goes to 1. All right? Notice I'm not putting brackets on there because at that particular point, nothing's happening there. That card is flat. So I would say decreasing. Well, then what happens after 1? So from 1 to infinity, right? So that's how I do that. So those are called intervals of increasing and decreasing. All right? So we're interested in those maximum minimum points, and we're interested in whether it increases or decreases. All right? And I'll give you some, and we'll graph them in decimals, because that's probably what you're going to do anyway. All right? And we can go from there. Okay. In your book, on page, they actually do a pretty good job of explaining it. It's better than I could. Where is it at? I was just looking at it here. Oh, here it is. 66. All right? So if you got your text on page 66. What they talk about is this even and odd function idea. I'll write it up here too, if you don't have it. All right, so on page 66 it says, determine even and odd functions from a graph. And it says definition, right here, definition. I'm going to abbreviate it. A function is even if for every x number, or for every number x in the domain, the number negative x is also in the domain, and f of negative x is the same as f of x. All right? That means that it's even. So what the heck does that mean? Well, one function that should come up to thought is that. Because if I take a negative number and square it, what am I going to get? Positive, right? So basically what this is saying is if I take a negative number and put it into my function, I'm going to get the same thing as if I put a positive number in there. Right? If I put a negative in there, I'm going to get the same thing as I put a positive. Well, there's a perfect example of it. Right? Y equals x squared.
That's for that formula, right? Which is the y equals x squared.
Yeah, so y equals x squared we would say is an even function. All right? Well, here's another one. See if you remember this. You remember what that is? Seen it before? Yeah, I see a couple heads going like this. What is it? Absolute value, right? Well, what happens if you take the absolute value of a negative? Get positive. Okay. Now, if we graph these, okay, here's this y equals x squared is a parabola. It's what? About what? Which axis? The y-axis. Yeah. So an even function then is going to be symmetric about the y-axis. That's how I can tell. Okay, so if I have symmetry here, all right, I can reflect it over that y-axis, all right, then it's going to be an even function, okay? So that's that one. And that's even. And below that, it says, a function is odd if for every x in the domain, the number negative x is also in the domain, and f, yeah, I didn't really want to do it that color, f of negative x is equal to negative f of x. So, in other words, if I have something that looks like this, all right, so here's my positive x's, I get this. But on the negative side, I'm going to have that same look, except instead of being above the x-axis, where's it going to be? Below it. It's going to look like that. All right? That's crazy. So if I have this here, when I do the negative part, it's just going to be kind of the reflection of it, but not quite. Okay? Now, this also is symmetric around the origin. Okay? So this one is symmetric around the origin. And it's really hard to see that symmetry. All right? And I wish I could, had some magic thing for you. But, if we all drew these on paper and I had patty paper, which I do in my room, and I put the origin there and I took this thing and I spun it 180 degrees, that's what it's going to look like. Okay, so if I can spin this 180 degrees, you can even turn your paper, I guess, if you want to, then about the origin, then that's symmetric about the origin. Okay. So this is odd. Now, I could be wrong, but I really don't think there's a whole lot of mathematics you're going to run into from here on out. It's going to talk about even and odd functions. I don't really know where it comes into play. All right. Some of the other stuff, yeah, that's pretty important, but I don't know. But I've seen it in a couple of different books, and I always wonder where it comes into play. But anyhow, that's even and odd functions. And there'll be a couple questions on your assignment where it says, look at the graph and tell whether it's even or odd. Right? And that's the best thing to do is just graph and try to look at it. The even's easy to part, the odd's not so easy. Okay, one other thing here, and then we'll go into Desmos and do some other things. All right. I'm going to draw another cubic, I think. Yeah, let's do that. Okay. This talks about a secant line. And it talks about a rate of change. Now, you did a lot of rate of changes someplace along the line, right? Because when you think of rate of changes and graphs, hopefully the word slope comes to mind. Because that's what slope is, right? When I would do 95 or 65 or whatever, 95 and 60, I talk about slope being a change in y over the change in x. Okay, that's what slope is. It is a rate of change, right? And if you're going to be taking this is kind of a little bit of a taste of calculus here. So if you take calculus, then you're going to be doing lots of this kind of stuff, right? So they say, okay, we have a rate of change here. And we're going to talk about the slope, the change in y over the change in x. So if I draw a secant line from here to here, right, and I know that this point is 2, negative 5, and I know that this point is 5, positive 10, all right, then the rate of change between those 2 points is just going to be the slope, change in y over the change in x. All right. So then we would just simply take 10 minus a negative 5 over 5 minus 2, 15 over 3 equals 5. All right. Okay. That's called a rate. That's what they call it. They call it finding I believe it is the rate. What are they? The rate of average rate of change. That's what they call it. The average rate of change. Okay. Now, let's say we have this, okay? And this is a parabola which describes a motion, throwing a baseball, kicking a ball, shooting a basketball, whatever, any type of projectile motion, all right? If I want to find the, we talked to somebody that mentioned velocity in one of the graphs. If I want to find the velocity at a certain point right there, okay, then what I have to do is draw a line here and find the slope of that line, okay? Problem is I only got 1 point. I can't find the slope at 1 point. So then what we do is we put another point real close to it, and we find the slope of that line. And that kind of gives us an approximation. And in calculus, what you do, oh no. In calculus, what you do, is it going to come back? What happened? I don't know what just happened. Ruined everything, right? Anyway, in calculus, what happens is, maybe if I hit this again, I don't know what happened. Anyhow, this is why you don't use technology. What you do is you take this distance and you make it very, very, very small, all right, and then you find the slope of that, and then you spend, I don't know, a couple of weeks doing that kind of stuff. Okay. That's what you do. Call the derivative. All right. So, but don't tell anybody that you take calculus that I told you to. Oh, that guy shouldn't be teaching that stuff. All right. But anyway, that's what it is. That's what they're warming you up to. Okay. So let's do some graphs here in Desmos and find some min-maximums and find some intervals of increasing and decreasing, and do that, because that's fun. And you can do your phone on this if you want to. All right, you just got to figure out, because you're definitely going to use it at home, so you probably need to use it at one point or another. Most of the ones in the, most of the problems that are in the book are graphs. They're already graphed for you. Some of them are equations. Myself would probably just give you a function, say you could graph it. I'm not going to give you a graph. It takes too much paper. So, all right, let's do it. So let's type one of these in. Y equals, let's go with x